Hello learners, this is Mr. Beckwith and you are watching another episode of Flashback Fridays. On this episode of Flashback Fridays, we are going to take a look at topography using satellite images and topographic maps. We will be in Arizona looking at the Grand Canyon. We will be in Colorado looking at the Great Sand Dunes. And we will take a trip to the coastline of Texas to take a look at some river deltas. We're also going to take a look at some topographic maps in a location that you may have seen before, and maybe you weren't thinking about it as a school subject. So let's take a look. So the first topographic map we're going to look at comes from the video game The Legend of Zelda: The Breath of the Wild. And here we have Link standing on the edge of a tall cliff. If we take a look at the topographic map, we can see the contour lines are really close together. The contour lines represent the three-dimensional landscape on a two-dimensional space. On this clip, we can see Link is now on a flat area that kind of slopes downward gently, and he's sort of moving downward on the slope. If we take a look at the map for this, we can see the contour lines are spread apart. So let's take a look at exactly how the contour lines function. So topographic maps show us changes in elevation, and specifically they also show us the specific changes in elevation for landforms using a two-dimensional format. So this is a way for us to understand what's happening three-dimensionally with a two-dimensional tool. And so here in this first example we're going to see we have our topographic map on the left, and then the actual what the side view, the elevation changes would be on the right. And you can see that as the contour lines go up, the elevation goes up. Now this is very beneficial, especially if you are planning a trip, or in the case for us today, taking a look at erosional features. The second image that we're going to look at goes into a little bit more detail about how to read the contour intervals and what those number values actually mean. So in this particular map, about every 10 lines we're given a number value going from 100 to 200 to 300, and that shows us the elevation changes. But the contour lines in the middle, those have a number associated with it as well. We just don't have them labeled. And so we can actually calculate for each one of these lines what is the change in elevation. And we do that just by looking at what's the difference between 100 and 200, and then how many lines are there between the 100 line and the 200 line. And so then we can actually calculate out that each of these contour lines represents a contour interval of 10. Now, we can't see from the key because it's a little bit too small to see on the screen. We don't know if it's meters or if it's feet. All that we know is that each contour interval represents a change of 10 units. And then we can look at the three-dimensional representation on the left and see that it's a pretty consistent slope going up. And again, referencing back to the map that we looked at in Breath of the Wild, where the contour lines are really spread apart, that tells us that the change in elevation is very gradual. If the contour lines are really close together, it means that the change in elevation is really extreme, like a cliff. Let's take a look now at Mount Aylesworth, also named Boundary Peak 176. It's kind of a bland name. I think Mount Aylesworth is a lot cooler. So Mount Aylesworth has some really interesting things happening as the snow and ice move down. And if you can see, there are several points here and here and here and here where we have these snow and ice flows. And as the water melts, eventually we get rivers and tributaries coming off of it. But what I want you to notice is what these ice and snow flows, what they are creating along the way. And they're actually creating a U-shaped glacier valley. Now, sometimes we can kind of see over here the effects when it carves out deep enough, we get a very wide river that flows down. And that could be the case here as well, depending upon the elevation. But this is an example of snow and ice causing weathering and erosion and causing landforms. Let's take a look now at the Mississippi River Delta, which is actually just southeast of New Orleans. And when we zoom in, we can very clearly see the river as it meets the ocean splitting off into several smaller spots as it empties out to the ocean. And as we have talked about before, the reason for this is that over time, and because the Mississippi River specifically runs the entire length just about of the United States and empties into the Gulf of Mexico, all of the sediments that are picked up and carried along, they're going to be deposited over time in this area. And you can see that this river has been depositing sediments. Really, all of this area was probably formed by sediments deposited by the Mississippi River. New Orleans itself is actually under sea level in many spots. So you can very clearly see here all the spots where sediment is being deposited, and new land is continuing to be added as those sediments build up. So let's take a look at some wind weathering and erosion through some satellite imagery. I'm using Google Earth, and we're in Colorado, and we're going to actually go to the Great Sand Dunes National Park and Preserve. So if we zoom in from Google Earth, we are going to see these sand dunes. Now, from the satellite imagery, it's a little bit hard to understand the scale. So let's take a look at this. So this is an image of what it would be if you were on the ground here. This is actually an image from this marker. And these sand dunes, they are huge. They are massive. And if we were standing at this point looking out, we would see them almost covering the entire horizon based on that perspective. But we can very easily see through the kind of irregular, smooth contours. It's very easy to interpret weathering and erosion of this sand by the wind. So the last spot we're going to take a look at is Grand Canyon National Park. We are in Arizona, and it is very clear that you can see the weathering and erosion happening by the Colorado River, moving through the Grand Canyon, weathering and eroding just an immense amount of land and material. And you can see it over here on the right in the three-dimensional view. It's very obvious to see how much land has been weathered and eroded away. But we can also see it pretty clearly from the satellite view as well. All right, learners, this is going to end our Flashback Friday for weathering, erosion, deposition for satellite imagery and topographic maps. We'll talk to you guys again soon.